The organs of the nervous system you will be studying today include cerebrum, cerebellum, spinal cord, dorsal root ganglion, and peripheral nerve.
The cerebrum is divided into two layers, the superficial cortex and the deeper medulla. Medulla, however, is not seen in this particular slide. Let us shift to LPO. The cerebral cortex is made up of 6 sublayers. However, under HE stain, only 3 of the 6 sublayers are visible. The most superficial is the molecular layer. Below the molecular layer is the granular layer. Below the granular layer, we can now find a characteristic cell of the cerebral cortex, which is the pyramidal cell. Let us now shift to HPO to view the pyramidal cells. The characteristic neuron of the gray matter of the cerebral cortex is the pyramidal cell, which is named for its triangular cell body. These cells feature a thick branching dendrite that extends towards the surface of the cortex. The cerebellum is composed of 2 layers, the deeper cerebellar white matter, or medulla, as shown by the black arrows. Superficial to the medulla is the cortex, as shown by the arrows. Let us now view the cortex at LPO to visualize the 3 cerebellar cortex sublayers. The cortex is made up of 3 sublayers. The most superficial is molecular layer. The deepest is the granular layer. Sandwiched between these 2 sublayers is the Purkinje cell layer. Let us now view the Purkinje cell layer at HPO. The characteristic neuron of the cerebellum is the Purkinje cell. These are very large neurons, most notable for their tree-like branching dendrites. They form a single central layer in the cerebellar cortex. This sublayer is sandwiched between the deeper granular layer and the more superficial molecular layer. On scanner view of the cross-section of the spinal cord, many important features are visible. The white matter makes up the outer region of the cord and is composed of ascending and descending nerve fibers. The gray matter is located in the center of the cord and is easily identified by its butterfly shape. The gray matter contains cell bodies, which we shall view at HPO. A neuron in the spinal cord gray matter is easily identified by its large size, cell shape, and extension from the cell body. The nucleolus within the nucleus is also very prominent, thus the descriptive term fish eye or owl's eye nucleus. Oligodendrocytes are identified by their dark staining small nuclei. Oligodendrocytes are derived from the ectoderm and are the myelinating cells of the central nervous system. Astrocytes are identifiable by their large light-staining nucleus. Astrocytes are derived from the ectoderm. They are supporting cells that are responsible for the blood-brain barrier and regulate the metabolic environment of the CNS. Microglia can be identified because of their elongated nucleus. Microglia are of mesodermal origin and are phagocytic. The central canal lies in the center of the cord and contains CSF. Ependymal cells, which secrete CSF, line the central canal of the spinal cord. These cells are cuboidal to columnar in shape and have cilia or microvilli on their surfaces to help circulate and absorb CSF. The dorsal root ganglion lies beside the spinal cord. The dorsal root ganglion contains the cell bodies of sensory neurons. These neurons are pseudo-unipolar. Fibers leading to the spinal cord travel through the dorsal root. Let us now view the ganglion cell at HPO. At HPO, we can now see the cell body of ganglion cells, which are sensory neurons. Their cell bodies are ovoid in shape. These neurons are pseudo-unipolar. Each ganglion cell body is surrounded by several satellite cells, concentrically arranged around ganglion cells. Satellite cells are of neural crest origin. They are also called capsule cells. The scanner view of the nerve allows you to visualize the different layers of connective tissue that comprise a nerve bundle. Fascicles of axons are surrounded and bound together by perineurium, which appears much thicker. Finally, an outer sheath of epineurium surrounds the entire trunk. Let us shift to LPO. At LPO, we can see that axons are arranged in fascicles and are bound collectively by perineurium. Let us shift to HPO. At HPO, we can see the dark staining structure shown by the arrow. This is the individual axon. The pale surrounding area is the myelin sheath covering individual axon. Each axon is then ensheathed in a layer of endoneurium.
And those are the organs you will be studying in the laboratory today. This video serves only as a guide, and you must study the actual slides on your own.